Hi students, in this video we're going to look at how to sketch and draw half planes with inequalities. Alright, so after watching this video you should be able to sketch the region of a half plane written in either gradient intercept or standard form, and also identify the overlapping region of two or more half planes. So a couple of things to recall. First of all, the two forms of a straight line. So gradient intercept form, y equals mx plus c, where m is our gradient, c is our y-intercept, or some constant, and then standard form, ax plus by equals d. You'll also need to remember from previous lessons inequalities and how to solve them. You'll also need to remember how to graph straight lines. Alright, so the first question we have to ask is, what is a half plane? So if we think about an inequality with an x and y variable, there will be infinitely many different solutions that will satisfy the inequality. Now, the only thing is, it will only be on one side of a given line. So for example, we've got an inequality here, which is y is greater than 1/3 x plus, not plus, subtract 2. Now, anything above this line makes this inequality true. Anything below this line, which is y equals 1/3 x minus 2, will not satisfy the equation. So for this reason, we say that this inequality gives us a half plane, because our Cartesian plane, which goes on and on to infinity in our x direction, also on and on to infinity in our y direction, this line will cut that plane in half, and only half of the plane will satisfy the inequality. So either the top section or bottom section, or if you want to think about it, a left section and a right section. And this region that satisfies the inequality is known as a half plane. So there's some language here about a corresponding linear equation. So if this is our inequality here, y is greater than, in this case greater than or equal to 1/3 x minus 2, then y equals 1/3 x minus 2 is the corresponding linear function. Now steps for sketching half planes are: identify if a dashed or solid line is needed. So for lesser than or greater than inequalities, a dashed line is used, so that's dash, 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 with our arrows on the end. For lesser than or greater and equal to inequalities, we use a solid line. So there's a difference there in terms of how we graph it. So exclusive inequalities, so not counting those numbers, not equal to dashed line. If it includes an equals to, solid line. So first step is to work out which line we need. The second step is to draw the corresponding linear equations. So we talked about before, if our inequality is y is equal to or greater than 1/3 x minus 2, then the corresponding linear equation is just y equals 1/3 x minus 2. So we have to sketch that corresponding linear equation and put it in on our graph. And then finally, identify the region to be shaded. Now, our first step is to recognize if the region is for large values of y, so y is greater than, or y is greater than or equal to, that means y has to be large numbers. So if our inequality is written like that, it makes sense that we use, on our Cartesian plane, all the large numbers for y. So our region will be above. If we've got y is less than, or y is less than or equal to, we'll use smaller values of y, negative values of y, and our region will be below the line. The other way we can work out which region we're looking at, which half plane satisfies our inequality, is just substituting in 0, 0. If it makes the inequality true, the side containing 0, 0 is shaded, or if you sub it in and the inequality is false, then the opposite side of the line is our region that we're looking for and needs to be shaded. So let's do an example of this. So let's sketch the half plane given by y is greater than or equal to half x plus 1. So first step, it's greater than or equals to, so we're going to use a solid line. Now let's sketch our line. So our y-intercept is 1, our gradient is half. So a run of 2, a rise of 1. There's our second point. And there's our line. That's y equals half x plus 1. Now, which region do we have to shade? Well, our inequality is y is greater than, y is bigger than this value. So where are all our bigger values of y? Well, they're up here in our positive y-axis. So we can shade in the region above this line because our y values are bigger than, they are greater than this line we've been given here. And that's how simple sketching half planes is. All right, so in this example, we're now going to identify the overlapping region between two half planes or two inequalities. And this is the second part of that learning goal we talked about at the start of the video. Now, the half plane given by y is greater than or equal to half x plus 1, we've already sketched that one. We did that on the previous slide. Now this one, the second one, 3x plus 10y is greater than 15, we'll have to draw ourselves. So the first step, looking at our inequality sign, we are using a dashed line because it is not greater than or equal to, it's only greater than. So we're using a dashed line for that. Now sketching our corresponding equation, it's y equals 3x plus 10y equals 15. We could rearrange, get y on its own, or just because it's written in standard form, we can use our x-intercept and y-intercept method of graphing. So our x-intercept is when y equals 0. So subbing that in, 3x equals 15. So our x-intercept is 5, just by rearranging. For our y-intercept, x equals 0. So 10y equals 15. Y equals 1.5. So plotting those points, there's my x-intercept. Then there's my y-intercept. Then there's the line we have to sketch. Now the question is, which region are we interested? Are we going to shade in? Will it be above or below? Once again, we could substitute in, get y on its own, and see which region makes the most sense. Or we can just sub in 0, 0, and see if our inequality is true or not. Subbing in 0, 0, we get 0 plus 0 is greater than 15. 0 is greater than 15. That is false. So that is not true. So what that means is 0, 0 is not in the region. So it can't be, we can't be looking at the region underneath this line where 0, 0 is at the origin. We must be looking at the region above the line, which I've just colored in green there. Now the overlapping region is where, obviously, where these regions overlap, which is this section up here that's a bit darker than both of the other two. And that's how we sketch overlapping regions, by combining them together and seeing which sections literally overlap. Alright, so to review our learning goals, students, after watching this video, you should be able to sketch the region of a half plane written in gradient intercept form or standard form, and also identify the overlapping region of two or more half planes.